Example, welcome to Bhutan e-learning project. I am Sonam Chiki and this is mathematics lesson for Key Stage 4 classes 9 and 10. Today we are going to learn about networks. Now, before moving on to the concept of network, I would like you to know that by the end of this lesson, I want each one of you to know what a network is. Secondly, by the end of this lesson, I expect you to know how to describe a digraph with a matrix. Then thirdly, also to create a digraph from a matrix. Then finally, you should also be knowing how to solve a network problem. Now to move on. Network is a connection. When we say connection, it's a set of connection between people. It can be a connection between destination. It can be a connection between activities. Now when I say network, and if I choose an example of a destination, let's say we have a destination A, B and C. And then we have a route from the place A to B. Then we also have a route from B to C. Then let's say we have a route from A to C as well. Then let's say we have a route from B to A. So the representation that I have here is called a network. And the 3 points or the destination that I chose, namely A, B and C, these are called vertices in mathematics. So we have 3 vertices. Each of this is a vertex. And the route that I choose is written by a line. So this line is actually called an edge. So we have 1, 2, 3, 4 number of edges. This is the concept of network. Now to move on, we need to learn how to describe this particular network using a matrix. Describing a digraph using a matrix. So, as I already said, we have 3 vertices in here, which gives us a matrix of the order 3 by 3. How is it so? We have A, B, C on the top of the matrix. And we also have A, B and C along the matrices, which makes the matrix of the order 3 by 3. So what you have to keep in mind is that every matrix that we get from a digraph will always be a square matrix. Now how do we fill up this particular matrix? We just have to look into your digraph and then see if we have a route from each place to other or not. Since we do not have any route from A to A, I put 0 here. There is a route from A to B, which gives us 1 here. So this is from and this is to. So I'm getting A to B with 1 because I have 1 route from A to B. Then to C, A to C, I have 1 route, so that's why I put 1 here. Now to move on to the second row, we will see from B. B to A, we do have 1, so put 1. B to B, we don't have any, so put 0. B to C, we have 1. And then, particularly this vertex C, have no arrow that is going out of the vertex, which means all the elements in here will be 0. So this is how we describe a digraph using a matrix. Now, the third concept is how to create a digraph from a matrix. So, if we have a matrix again, and let the matrix be again of an order 3 by 3, it can be of any order. It can be 2 by 2, it can be 4 by 4, 5 by 5. I'm choosing this one. Let's say 0, 1, 2, 1, 1, 1, 0, 1, 1. Okay. So for this matrix, if I'm asked to make a digraph, first thing that I need to know is how many vertices do I have here. I have 3 vertices. That is because I have 3 rows and 3 columns. So let's put this vertices A and name it, alright, A, B and then C. I place this vertices A, B, C in this order. It necessarily need not be in this order. I can place my A somewhere here and keep this as B and C. So my digraph and yours may not exactly be the same because of the placement of the vertices here. So now we do not have any from A to A. So let's say this is A, B and C, A, B and C. A to A, 0, so I don't do anything. A to B, I have 1 root, so A to B I draw 1 like this. Then A to C I have 2 roots, so A to C I will have to draw 2. And make sure that you draw the arrow along with it to show that, that the direction is moving from A to C. This is actually called a directed graph. Okay, this is called a directed graph because it has direction given. Then we have B to A, 1 root, B to A. Then we have B to B. Now here is the special case. When I say B to B, how do we make the root? We have to make a loop here. The circle thing that I make here is called a loop. This represents that there is a root from B to B. Then B to C, 1. Then C to A, I have none. C to B, I have 1. Then C to C, again 1, which makes another loop here. So this is the digraph that we get for this particular matrix. Now, next what we need to know is some of this edges or the root can be simplified. When do we simplify? If a root is coming down and going up from the same place to the other one, which means if it is a bidirectional, in that case we can simplify. How do we do it? We have vertex A here, vertex B here and vertex C. As I said, there is a root coming down as well as going up from A to B. 2 of these roots can be simplified using 1 line with no direction. So 2 of these roots can be simplified using 1 line with no direction. And then we have 2 here. Since there are only 2 roots from A to C, it's okay to write the roots again. If we have around 7 to 8 roots from A to C, I can write just 1 and write 7 or 8 here. Then we also have a root from C and B going to and fro. So for that, I can simplify using 1 line. Then we have loop for B. We have loop for C. This is the simplified form of the digraph for this particular digraph. I hope it is making some sense to you. To move on, solving network problems has to deal with one concept of 1 stopover trip and 2 stopover trip. So I'm going to move on with 1 stopover trip. So what does this mean by 1 stopover trip? We have looked into the routes, we have looked into the trips going on from one place to another. What is this 1 stopover trip? We have a point A here. We want to go to point C here. If we take a direct route from A to C, there is no talk about this 1 stopover. What we have to keep in mind is to go from A to C, if I stop somewhere here in B, go to B, then to C, this is a concept of 1 stopover trip. To go from A to C, I stop somewhere in between, which is point B. So this is the concept of 1 stopover trip. Let's look into detail. Okay, if this is the network and I want to find one stopover trip for each of this, what I need to do is I need to find out the initial point and the end point. So if my initial point is A and then my end or the final destination is A, I need to go to a place somewhere in between A to A and then come back to A, which is not there in here. If we had a route from A to B, then coming back to A, that would have been possible. But here we don't have any, so you put 0. Now, the concept will be clearer if you look into further. My initial point is A and my final destination is B. But before reaching B, I need to stop somewhere. So, I go from A to D, then from D to B. So, A to D to B makes one stopover trip from A to B. Similarly, you move on A to C. We can go from A to B. Then we have a route from B to C. So we have A, B, then to C. The main concept in here is you have to keep in mind the initial point and the final point. In between, you will have to have one point or a vertex. So A, B, and C. Just let's see if we have some more. No. So that's good. Then we have A to D. To go to D, we have a direct route. That is not a one stopover trip. Keep that in mind. A to D is not a one stopover trip. We have to go somewhere which is not there, so we put 0. Then finally, A to E. So we can go from A to B, then to E. So we have one there. A to B, then to E. If you see carefully, there is one more route to go to E, stopping somewhere else. That is A to D, then to E. So A to D, then to E. So here we have one stopover trip from A to A. Similarly, you will have to do find out for B to A, B to B, B to C, B to D, and B to E. Now to move on to the concept of two stopover trip. You already know what a one stopover trip is. So two stopover trip would make sense. Then it would mean that we will have to stop at two different places before landing on to your final destination. So A to A again. Just have to check. You have to do this on a trial and error basis. There is no specific method to find this out. So what we have is you go from A to D, then to B, then to A, but we don't have a route from B to A. So again, for two stop, this is for one stopover. And now I'm going to show you for two stopover. A to A again, there isn't any, so I put 0. Then A to B, A to B. I check A to D, then to E, but there is no route from E to B, so again 0. A to C, I can go from A to D, then to B, then to E. So I think that makes sense there. A, we're going from A to C, right? Okay, A, D, then from D I can go up to B, then there is a route from B to C. So here you can see the difference. I stopped at two different places before getting to my final destination C. So that's how you move on to find one stopover trip and two stopover trip. This is not the end. We have to find for A to D, A to E. We have to find for B to A, B to B, B to C, and so on till we have it from E to E. That would mean in total we should be having 25 numbers of initial point to the end point. So this is one method of finding one stopover trip and two stopover trip. The other method to find one stopover trip and two stopover trip is by using matrix. So how do I use matrix in order to find one stopover trip? First step, you have to find adjacency matrix that you have already learned. So how do we make adjacency matrix for this? We have to first, it's some sort of a recapitulation of the previous topic. A, B, C, D, E along the top of the matrix. A, B, C, D and E along the side. So this is an adjacency matrix, and as I said earlier, we should have a square matrix for an adjacency matrix. This is a matrix of the order 5 by 5 because we have 5 number of vertices. A to A we have no root, so put 0. A to B we have 1. A to C we have none. We do have a one stopover trip but not direct root, so we put 0. Here adjacency matrix is the direct root. A to D 1, A to E 0. B to A 0, B to B 0, B to C I have 1, B to D 0, B to E I have 1. Then move on to the C. C to A there isn't any. C to B we have 1, so 0, 1. C to C 0, C to D, which is this one, we have 0. C to E I have 1. Then comes D. D to A 0. D to B there is 1 root, so I put 1. D to C 0. D to D 0. And D to E I have 1. Now E. And as similar to the previous example, E is a vertex with no arrow going out, so I directly know that the elements are all going to be 0. Now what do I do with this adjacency matrix to find one stopover trip? Let's name it at matrix 1. Before moving on to finding one stopover trip, if you look at the principal diagonal element here, this is the principal diagonal. The address of this is 1, 1. This is 2, 2. This is 3, 3. 4, 4. 5, 5. This is called a principal diagonal elements. Here all the elements are 0, which means in the digraph we do not have any loop. So with that, I'm saying M1, let this be the matrix. To find one stopover trip, M1 that I have has to be squared. So when I say it has to be squared, I'm multiplying M1 with M1 to get M2. And what does this M2 mean? M2 will give us the matrix which will give us one stopover trip. We need to multiply 0. I need to multiply this matrix with the same matrix again, which gives us the concept of matrix multiplication is already shown to you the previous lesson. So here I'm not going to show the steps, rather I'll directly get the product. So we need to multiply this row to this column in here to get the product. And as you can see, the first column in here are all 0, so I'm sure that my product will also be 0. And then to move on, the first row with the second column, because it's a huge matrix, I don't want to get confused. I'm highlighting the one that I am multiplying. So we have 1 in here. Then now I'm going to multiply the first row with the third column. So we can have 1 in here. As I said, I'm doing this multiplication mentally because this lesson is already taught to you. Then next I'll get 0. This with the last one, I'll get 2. Now the second row with the first column again, and because all the elements is 0, I know for sure that there is 0 in here. Then 1, this with the third column, 0. The second with the fourth column will also give 0. Second with the fifth column gives me 1. Now similarly we have to do the same for the third row, fourth row and the fifth row. So what do we get here? This is A, B, C, D, E. If you remember properly the first method that I showed using the digraph, you have seen that there is no one stopover trip from A to A. This is what it shows here. And then if you look into A to B, there is one stopover trip from A to B. There is one stopover trip from A to C. There isn't any from A to D, and here 2 would mean that there are 2 one-stopover trip from A to E. So the rest I want you to do it on your own. Multiply it. Then this is how we find one stopover trip using matrix. Now what about finding 2 stopover trip? I took this as matrix 1. This is also matrix 1 because they are the same. Let's say the product matrix that we have here is matrix 2, M2. Now I want to find 2 stopover trip using the same matrix method here, which is quite feasible compared to that digraph method, because here there is no way that you can make mistake, but using digraph what you can do is there is a possibility of you to skip some of the steps. So 2 stopover trip using matrix. What you need to do is you have to cube the matrix. When I say you have to cube the matrix, we already have matrix after squaring, which is matrix 2, M2. If I multiply M2 to your M1, which is the original one, the adjacency matrix, we will get M3. And this M3 is actually the 2 stopover trip matrix. So from here, as we see one stopover trip, if the elements are 2 here, it would mean that there would be two stopover trip from A to E. That doesn't guarantee that it has to be 2 there. I'm just giving an example. So with this, I have few questions for you to try at home. Question number 1. You have a digraph given. What I want you to do is, I want you to create an adjacency matrix for the given digraph. Question number 2, I would want you to find out how many one stopover trip are there. Then question number 3, I also want you to find out how many 2 stopover trips are there. So with this, I'm expecting that you have learned quite a lot today. To recapitulate, firstly, you have seen what a network is. Network is simply a connection And then connection could be between people, it could be between destination, it could be between activities. Secondly, we have learned how to describe a digraph using matrix. Third, we have done just the opposite. We have learned how to draw a digraph from a matrix. And lastly, we have looked into the concept of one stopover trip and two stopover trip. Thank you all. I hope you have enjoyed. See you in next lesson.